Okay, I'm going to do a few examples of factoring out polynomials that are raised to rational exponents such as fractions and negative numbers, because sometimes that can get a little confusing. So, let's start with one. Let's start with, I'm going to have x plus 1 to the negative 2/3, okay, plus x plus 1 to the 1/3. And although this may look extremely intimidating, it really isn't. Fractions are numbers too. So you're just going to factor out your common factor just like you would if you had integer exponents. So the first thing you want to do is make sure you have the common base. So you can see both of these have the x plus 1. So that is going to be what you factor out. That's the polynomial you're going to factor out. The question is, what's the exponent you're going to raise it to? Well, just like when you have integers, you want to look for the smallest exponent. And hopefully you realize that negative 2/3 is definitely smaller than 1/3. So that will be your exponent that you take out. Oh, I can't make that little 3. There we go. All right, so now inside the parentheses, okay, so just ask yourself, what am I going to multiply x plus 1 to the negative 2/3 by to get the same thing, x plus 1 to the negative 2/3? And again, hopefully you realize that, oh yeah, I just need to multiply that by 1, okay, because I'm getting the same thing. Okay, now we're going to put our little plus sign here, and now we got to see, okay, what am I going to multiply x plus 1 to the negative 2/3 by to get x plus 1 to the 1/3? And you're probably thinking to yourself, heck, crap, I don't know. Well, let's just come over here and just think about what's going on. So we know if we were to redistribute this, so if we were to remultiply whatever's here by whatever's out here, we need to get this value here. So in a sense, if we're going to take x plus 1, let's hopefully have room, x plus 1 to the negative 2, that's a 2/3, that's a 3, ugh. Okay, see if I can make that a little bit better, 3. Maybe I should just erase that, sorry. Don't mean to slow this. Oh, how about we just erase the whole thing? Let's just try again. Okay, so I'm going to take x plus 1, okay, to the negative 2/3. Oh, that's a much better 2 anyway. And can I make the 3? Okay, that looks a little more like a 3. Okay, and I know I have to multiply that by x plus 1 to something. Let me get that closer. To some exponent. So that I end up with x plus 1 to the 1/3. Again, think about what you do. Once you finish what you have here, if you redistribute, you should end up with what you started with, which is why we want to take x plus 1 to the negative 2/3 times x plus 1 to something. That's this guy over here. So that we end up with x plus 1 to the 1/3. Okay, well, let's take another closer look. Notice here we are multiplying, okay, and we have exponents. Well, if we go back to our MADSPM rules, when we multiply, we end up adding the exponents. So you can think of this as, well, gee, I have to take negative 2/3 and add something to negative 2/3 so that I get a positive 1/3. Well, let's see. Negative 2/3. Well, I know if I take 3 minus 2, I get 1. So it looks like I'd be taking 3/3. Okay? And that is what goes up into that box, which means this right here needs to be x plus 1, parentheses, raised to the 3/3. over 3. Now you're probably telling yourself, well, gee, 3 divided by 3 is 1. And you are exactly right. So this is the same thing as x plus 1 to the negative 2/3, and then parentheses 1 plus, well, x plus 1 to 3/3 is just x plus 1 to the first. Well, that's the same thing.